Hello everybody. So today we are going to be doing lesson 1.5. And lesson 1.5 is talking about something called the nth root. So nth root. This is block de numero 2. So how do we describe the nth root? The nth root is kind of like if you think about a square root. So this is similar to a square root. So an example of this would be like 2 is the cube root of 8, right? So we know if we took 2 and cubed it, we would get 8. So then if we took the cube root of 8, we should get 2. Another example would be like 3 is the fourth root of 81. So that means that if we took 3 and put it to the power of 4, we get 81. Just like if we took 81 and put it to the fourth root, we would get an answer of 3. So the generalization of this, why did I add the AL at the end? I don't know. Generalization of this, so generalization just means using letters instead of numbers, would be that when n is a number larger than 1, so if n's larger than 1, then our b of n equals a, so b to some power is going to give us an answer. B is said to be the nth root of a. So we would write this as n, the nth root of a. Another way to write it is going to be the answer B. So when we write it in this form, so this form right here, this form is called a radical. And I don't mean like, yeah, I caught that wave, it was really radical. I mean like it's a radical expression in math. So it's pretty cool in math too. I'm sorry, it's been a long day. I'm gonna be lame. Radicals can also be written, so radicals can also be written as a power. And what do we mean by that? So we were just dealing with the exponents. Radicals can be written as an exponent. So instead of writing this root symbol, now we don't necessarily have to write the root symbol. Now we can write an exponent. So the way that we do that is, if we were looking at the square root of a, the radical version has this symbol in it. Writing it as an exponent, we put it to the 1/2. Not gonna lie, I don't remember where I left off. So if we looked at a different example, say that we were taking the cube root of a, the way that we would write that as an exponent is the cube root, so we take a to the 1/3 power. And I'm going to explain what this means more the further that we get into this lesson. So if we had the fourth root of a, we've already talked about a fourth root up here. So if we have the fourth root of a, it means that we are just taking a to the 1/4 power. So now we know how to write a radical as an exponent. This continues too. If you took the 5th root, the 6th root, the 7th root, you could take whatever root of whatever number you wanted to. You can use all the same properties. See, that should be an IES, right? So same properties of exponents can apply. So by that I mean like the power of powers property, the product of powers property. So with that said, the power of powers property. So if we had the square root of a, so a to the 1/2 squared, we could multiply that through. So that would mean we take those two exponents and we multiply, so I guess I should write the 1/2 because it's first. So 1/2 times 2, which would just equal a to the 2 over 2, which equals a to the 1, which would just equal a. So that would be pretty basic, right? We could also say we have a to the 1/3, and we take that to the 3rd power. So then we would have a to the 1/3 times 3, which equals a to the 3 over 3, which equals a to the 1, and that's just a. So that same pattern could continue, although it doesn't have to. It's not always going to necessarily work out that way. Let's look at an example. So I'm going to get rid of this page and start a fresh one. Let's look at an example. Number 1. So the directions are to find the nth roots. Find the nth roots. For a, we are given that n equals 3 and a equals negative 27. So find the nth root. So that means that if we were to take our given values and set them up like this, we want to find what b equals. So 3 is going to be our nth root, so we're taking the cube root of negative 27. So now when we're taking the cube root of a negative number, we're allowed to do this. It's an odd number. So the only reason we're allowed to do it is because it's an odd number. If it's an even number, it doesn't work that way. So the cube root of 27. Another way to think of this is negative 27 in parentheses to the 1/3 power. So I told you guys I was going to explain what the fraction meant more. The fraction means we take this many pieces of whatever number can be multiplied this many times to give us this. So what number can be multiplied 3 times, so times itself 3 times, to give us negative 27? Well, the only number that would work there is negative 3 times negative 3 times negative 3. So that's the only number that can be multiplied by itself 3 times to give us an answer of negative 27. So if that's to the 1/3 power. So now to actually solve for what b equals, it says to take one of those. So you take one of those. So we just take one of those values, and now we get an answer of negative 3. So our answer for that would be negative 3. For example B, what if we had n equals 4 and a equals 16? So when we have kind of a higher number going for the root power, the root, and like a fairly small number to look at to take the root of, it's usually going to be 2. So if our root is even, it's usually going to be 2. So this would say the 4th root of 16. So what number times itself 4 times would give us an answer of 16? That should be a 1/4, sorry. So that is going to be 2 times 2 times 2 times 2 equals 18, or 16, sorry. And we want the 1/4. So 2 times 2 times 2 times 2, 4 times gave us 16. And now we're going to take one of those. So our answer should just be 2. There is some problems that follow this example in the book. So it's problems 1 and 2. Those are part of your homework. So I will give you those later. The next example that I want to talk about with you is example 2 in your book. So example 2. And example 2 says to evaluate the following. So evaluate. A is the cube root of -8. So again, just like we had the example up here, when we have an odd root, it could be a negative answer. So -8 to the 1/3 power just means what number times itself 3 times would give us an answer of -8. And then we take one of those. So our answer should be -2. For B, we have negative, so the negative is on the outside, cube root of 8. So now it's saying that there's this negative sign floating out here, and we are going to take the cube root of 8. So we do the parentheses first, and then the exponents. That should be a 1/3, sorry. So negative, and then 2 times 2 times 2 to the 1/3. If we just took one of those, that negative would still be out in the front. So our answer should be -2. So this is 2 different ways to get the same answer. Notice that. C, 16 to the 1/4. So 16 to the 1/4. It's already written as the fraction form, which is the way that I would like to think of it more. So what number times itself 4 times would give us 16? So that would be 2 times 2 times 2. And that's still to the 1/4 power. And now to solve it, we take one of those. It tells us to take one of them. So the answer would just be 2. And then the last little example for this one is going to be the quantity -16 to the 1/4 power. So the quantity of -16, what number times itself 4 times would give us a negative answer? So we might think -2 times -2 times -2 times -2 to the 1/4. But what happens when you multiply out all these negatives? So the negative and the negative cancel, and then the negative and the negative will cancel. So we end up with +16 to the 1/4, which is not what we started with. So this one's not possible. So that's what I was talking about. If you take the odd root of a negative number, it's possible. But if you take the even root of a negative number, you're not going to get an answer. It's not possible. There is one more example that I wanted to look at you with you guys, but we need to go over some terminology first. So if we said let A have an exponent of 1/n, 1 over n, so let this be an nth root of A, and let M be any positive integer. So an integer is a whole number, right? So then that would mean that we have this thing where we could write A to the M over n. So this is just a power of a power. We took and we multiplied. So we took and we multiplied A to the 1 over n times m. So I told you guys that the powers, the properties of exponents still worked. This is all that means. So we could further write that as the nth root of a to the mth power. So an example using numbers would be, say we had 27 to the 2/3 power. That looks really, really weird, but let's break it down like we did here. So we have 27 in parentheses, right? So 27 to the 1/3 power, and then we still have to write that 2, so that m would be a 2. So now from here, we are going to further separate it. What number times itself 3 times would give us 27? So 3 times 3 times 3. And we want 1/3 of that. So we take one of them, which would give us 3 squared. From here we can drop the parentheses. So 3 squared is 9. Right? If we were trying to rewrite it, we would have the 3rd root of 27 squared. And then from there you could simplify it further if you wanted to. So the last example, example 3, we have 2 problems that we are going to do. So A is 16 to the 3/4. So 16 to the 3/4, if we break it down, we have 16 to the 1/4, and then that's to the 3rd power. So what number times itself 4 times would give us 16? That would be 2. So 2 times 2 times 2 times 2. And that is to the 1/4 power, which is to the 3rd power. So then from there, we take one of those. So we have 2, and now it's to the 3rd power. So 2 to the 3rd power is 8. For B, we have 27 to the 4/3 power. If we break it down like we did in the last one, so 27 to the 1/3 and then to the 4th power. What number times itself 3 times would give us 27? So that'd be 3 times 3 times 3. And then we want 1/3 of that. So 1/3 of that, we're taking one of those, would be 3 to the 4th power. And 3 to the 4th power equals 81. So your homework that goes with this lesson is going to be in 2 different places. So the homework is going to start on page 36, and it will be numbers 1 and 2. And then it's going to be on page 37, numbers 3 through 6. So not too many homework problems tonight. Thanks for watching. I hope this makes sense. If you have any questions, please don't hesitate to email me or set up a Zoom with me or something, because I want to help you guys. Have a good day.